Okay, there's really two types of collisions. There's the elastic and the inelastic collision. And so what I'd like to do is I'd like to go through both of these because I think this is the core of the unit, right? Pardon me. If you can do these two problems, you can do most all of the unit. All right, so I've got two balls here. I got the gray ball called A, the white ball we'll call B. We have a collision happening, and then they go in the opposite direction. This says it's an elastic collision. All right, so what do we know if that happens? Well, let's get our knowns and unknowns first. So we know that the mass of A is 3. The velocity of A is 4.2. The mass of B is 2. And the velocity of B is 3.7. Although not quite, because it's going backwards. So assuming that we set this direction equal to positive, it's going negative 3.7. And then afterwards, we're looking for what's the VA prime and what's the VB prime. Okay, so when we set up our regular conservation of energy question, or equation, we've got the sum of all the p's equals sum of all the p primes. So that means PA plus PB equals PA prime plus PB prime. PA is going to be 3 times 4.2. PB is going to be 2 times negative 3.7. This is going to be the mass of A, which is 3 times VA prime, plus the mass of B, which is 2 times VB prime. Now, I've dropped a bunch of the units for simplicity's sake. Let me go grab a calculator real quick. All right, so if I solve the left-hand side of this, I'm getting 5.2. So that's what I've got. Now I have a problem because I have two unknowns, but only one equation. You can't solve that, right? Unless we use our equation that works for all elastic collisions. And that is VA minus VB equals negative the quantity, VA prime minus VB prime. This works for all elastic collisions. So I'm just going to plug in what I know. VA was 4.2, VB was negative 3.7, that's supposed to be negative 3.7, equals, and I'm just going to distribute out this negative. So 4.2 minus a negative 3.7 is 7.9. Now, I couldn't solve one equation with two unknowns, but I can solve two equations with two unknowns. That's a system of equations. So what I'm going to do is I'm going to take, if I can solve one of these, so if I solve this one for VB prime, that's going to be equal to 7.9 plus VA prime, right? And I can take that and I can say if that's VB prime, I can plug that in for VB prime over here. So VB prime becomes 7.9 plus VA prime. And then if I do some distribution, 2 times 7.9 is 15.8 plus 2 VA prime. I'm going to simplify that a little bit, so I have 5.2 equals 5 VA prime plus 15.8. And if I solve that, that's a regular algebra equation. And I get, I get that VA prime is negative 2.12 meters per second, which which makes sense because A is going backwards. And now that I found VA prime, I can just go back and plug back into this equation. So I'm running out of room here, but if I go up here and I just plug back into this equation, 7.9 plus negative 2.12 equals VB prime. So I'm just plugging that into this equation. And I get VB prime is 5.78 meters per second. And again, it makes sense that that's positive because it's going forward. So that's the basic elastic collision problem.